All right, students, it's time to start practicing for the midterm. Since this review is all review material, I'm going to try to blow through this as fast as possible. So anyway, let's go ahead and get started with number one. Number one is what we've been studying. We're going to write the equation of a line passing through the point 1, negative 1, negative 4 with a slope of 3. So I'm going to use my point slope form of the linear equation, x minus h plus k, where m equals negative 1, h equals negative, getting a little bit too excited here already. So our slope is 3, our h is equal to negative 1, so x minus a negative 1 is the same as a positive 1. Then we're going to add k to the end. K happens to be a negative 4, so it's adding a negative 4. Our 3 distributes to both terms to give us 3x plus 3 minus 4, which equals 3x minus 1. All right, let's take a look at number 2. We'll zoom out a little bit here. For number 2, on a certain cell phone plan, the cost for 6 additional minutes is $39.30, and the cost for 10 additional minutes is $41.50. So you need to recognize in this one that the problem gave you 2 data points. Therefore, when you have 2 data points, 6 and $39.30, and 10 and $41.50, that you need to know to construct a table. I'll write our table x, y, where x 6 minutes and 10 minutes. 6 minutes costs $39.30. 10 minutes costs $41.50. I calculate my change in y, which equals $2.20. And I'll calculate my change in x, which equals 4 minutes. So my slope is given by change in y over change in x. My change in y was 220. My change in x was 4 minutes. Therefore, my slope is 55 cents. For h, I'll go ahead and use one of those data points. H can be 6. K can be, K must, if I choose 6 for my h, K has to be 39.30. And so, what the equation we'll use is our point slope form. So y equals m times the quantity. I'm not going to write it out. I'm just going to drop the substitutions in there. So y equals 0.55 times x minus 6 plus 39.30. And the problem did not tell us that it needed the answer in slope-intercept form, so I'm just going to leave it in point slope. All right, let's go down to number 3. The following equations are in point slope form. Remember, point slope form is m times the quantity x minus h plus k. And so to put them in a slope-intercept form, we'll simply distribute, then add like terms. I'll distribute my negative 3 to both the x and then the negative 4. And then that gives us negative 3x plus 8. And that equals y. And then for number 4, will give us y equals 1/2 x minus 1 plus 3. And that gives us 1/2 x plus 2. And that equals y. Okay, let's go down to the bottom of page 1 here. Graph each equation on the provided graph. Alright, well, y equals x, that is the linear parent function, has a slope of 1 and a y-intercept of 0. And so y equals negative x will just be the mirror reflection of it. And it looks like that. Okay, we'll go to page 2 here. Write the equation of the line shown in the given graph. Okay, well, the easiest way to do this is to use our slope-intercept form, mx plus b. And so y equals our slope, which is down 1, 2, 3, 4, then over 1, times x plus b, and b is right here at positive b equals 2, plus 2. So this would be negative 4x plus 2. That equals y. Write the equation of the line shown in the given graph here. Okay, well, we see that our line is sloping upwards here, so we know that our slope is going to be positive, and it'll be positive 1 over 1, 2, 3, 1/3. So our slope is 1/3, and our b, let's see, 1, 2, 3, 4, 5. So b equals negative 5. So using our equation y equals mx plus b, our rate of change is 1/3 times x minus 5. Okay, for number 9 here, graph the line y equals negative 2x plus 1. Okay, well, I'll do that first here. So we'll go up 1, because that is our y-intercept, and it tells us that our line's going to be sloping downward, because of this little negative sign right there. And so it's telling us to go down 2, 1, 2, but this has like a little sneaky denominator of 1, so down 2, then over 1, drop a point. So there's our initial line, our first line. But then they're asking us to do something special to it. They're asking us to translate it down 5 units. So when we translate it down 1, oh, come on now, don't do this. 1, 2, 3, 4, 5. There's our new point there. We can translate this one down. 1, 2, 3, 4, 5. And we can draw our new line here. So there's our new line that's translated down 5 units. So the equation of our new line, it still has the same slope, same rise, same run as this one. So our slope doesn't change, it's still negative 2. But the y-intercept has changed. The y-intercept is no longer positive 1, it's now negative 4, because we translated every single point down 5 units. And the y-intercept here was plus 1, so if we subtract 5 from that, that brings us down here to 1, 2, 3, to negative 4, which is how I got that number right there. Parallel lines, they have the same slope. So if we want to write an equation that's parallel to this graph that passes through this point h, k, and we know that it's parallel, so that means that the slopes are the same, so our new line will have this slope, negative 4. So m equals negative 4, h equals 6, k equals 7, and we'll plug those all into our point slope form equation. Y equals negative 4 times x minus 6 plus 7. That equals negative 4x plus 24 plus 7, which gives us negative 4x plus 31. Okay, let's take a look at number 11. Here's the following function down here.